Hi, so we're going to continue on with our discussion about selection statements or if statements. Today we're going to be looking at an introduction to logic. So once again, in the Java 8 fundamentals, you can look at Boolean logical operators in chapter 4 and the basics about if-else statements in chapter 5. All right, so logical operators are used to create compound or combinations of Boolean expressions. They're similar to arithmetic operators for creating compound number expressions. Logical operators can combine Boolean expressions that are built using relational operators. And here's an example. So what we have here is a logical AND right here. And on both sides, or on either side of it, you've got an expression over here, and you've got another one over there. This one right here is asking the question, is 1 less than or equal to x, and over here what you've got is x less than or equal to 10. And so what we're asking is 1 less than or equal to x, and is x less than or equal to 10? That's the question that's being asked right here. Here's another one. Is x less than 1, or is x greater than 10? We consider three logical operators in this particular session. The logical negation, which is being represented by the exclamation mark, and we will tend to call it the not. We have the double ampersand right here, which is the logical conjunction, and we'll typically call it the and. The next thing that we have here is this double vertical bar right here. This is the logical disjunction, and we will tend to call it the or logical or. Logical negation is a unary operator, one operand being a Boolean expression. All right. So the result is the negated value of its operand. So for instance, we have the operand on this side over here, and if it's true, then the negated version of it will be false. If the original one is false, the negated one, or the nodded one, is going to be true. All right, so here's an example right here. So we've got a variable called radius. It's a double floating point type, okay, and we're going to take some input from the user using scanner. Okay, then we have another variable called isPositive, and it's of type Boolean, and it's defined as it's being associated with the value of radius, and the question is radius greater than 0? Okay, and it really depends on what the user has inputted. Okay, now there's an if statement right here with the corresponding else that goes along with it. And right here, the question becomes, execute the print line right here only if the result of isPositive is false. Okay, so basically if not the case that isPositive is true. Okay, so basically we want to know that if it turns out that positive is true, okay, that is that radius was greater than 0, then this won't be executed. It will only happen if isPositive was found to be false. Then the false becomes a true due to the not right here, and then we execute. Otherwise, what's in the else right here will be executed. All right, so we have the logical conjunction, and that's the and. Okay, so we'll refer to it typically as the and we have in previous classes like the MATLAB class. So the logical conjunction is a binary operator. That is, it operates using two operands, so one thing on either side of the conjunction, and so the conjunction is true only when both of the operands, so both things on either side of the and, are true. So the result is true if both of the things on either side of the operator are true. if one of the operands is false. So if one of the things on the left or on the right hand side are false, then their conjunction is going to be false. So here's some examples here. So so what we're talking about here is something like this, and then we have op1 and op2 like that. Okay, so left operand and right operand. So left operand, right operand, and then this is the logical and, or the conjunction. So if left operand 1 is true and right operand is true, then this right here, op1 and op2, is going to be true. Now we go through the rest of the truth table right here. If op1 is true and op2 is false, then the end result is going to be false. If the left side is false and the right side is true, then the combination of these two together, okay, is going to be false. Finally, if we have on the left hand side the result is false and on the right hand side it's false, then the combination will be false. Another way of writing this table right here would be to say 1, 1, 1, 1, 0, 0, 0, 1, 0, and 0, 0, 0. Okay? Like that. Here's another example right here. Or here's some sort of a coded up example. We have age is an integer. We have a Boolean variable called is old enough. We have another Boolean is not old enough. And so we have the user input here. Is old enough is assigned the value of true or false based on whether or not age, what was inputted by the user, is greater than or equal to 45. So if the user had inputted, say, the value 60, then is old enough would have a value of true. If the user inputted, say, a value of 30, then is old enough would be false. And then over here, let me see. So is not old enough. If it was 30, then age less than 65. So then this would be is not old enough would be assigned a value of true. And let's actually there should be semicolons there. I can't remember if the semicolon was there. I've erased it out of the brackets right there, the parentheses. So then after that we have an if, else combination right here. All right. So what we have is a question. If not is old enough. So if it turns out, so we entered 30. If we entered 30 up here, and that would be 30, and then is not old enough, is not too old would be true, and is old enough would be false. So that would be false. If false negated, that would be true. So then this would be true, and so we would have whatever statement in here. If there was a statement, this would be executed because the person would be considered young. Okay, and then the other two would be ignored. Now, if it turns out that we put in a value of, let me see, so we want to have something less than 65 and greater than 45. So if we had a value of 50, okay, so if we had a value of 50, then is old enough would be true. Is not old enough, is not too old would also be true. This right here, the first part, the true would become false. So the very first one would be negated. Okay, that wouldn't be, that would not occur. And then else if is old enough. So this would be true and true. So true and true. This would be, this right here would be found to be true. So whatever was in the curly braces right here would be executed, and then this would be ignored. So that's basically how this sort of thing would work. Here's a logical disjunction. A logical disjunction is a binary operator. That is, again, like with the AND. Okay, so a logical disjunction is what we often refer to as an OR. It has two operands, each being Boolean expressions. The disjunction is false only when both operands are false. If one of the operands is true, then their disjunction is true. So here's an example, or here's the table. Okay, so what we have here is operand 1 ORed with operand 2. So if the left operand, so we've got op1, logical OR, op2. So if on the left we have a Boolean value that is false, and on the right we have a Boolean value that is false, then what we end up having is a false combination through the OR. If the left-hand side is true and the right-hand side is false, then ORed together, the result will be true. If we have a false on the left-hand side and we have a false on the right-hand side, then false ORed with true will give us true. If both sides have a true, so true and true, true together with an OR between them will result in a true. Here's an example as well. So we have an integer that comes in, it's called age, and it's coming in because we're going to scan in using the input from scanner, and we're going to be considering it as an integer. Okay, so then we have two Booleans. We have is senior and is child, and is senior will be true. Oh, there should be a semicolon right there. Is senior will be true if, say, the value of age that came in was like 70. Okay, so it's greater than or equal to 65. And then your Boolean is child is only true if the age is less than 18. Okay, now, if I were to put in 70, then is senior would be true, is child would be false. So then down here in my if-else combination right here, if I've got, if I had 70 as an input from the user, then I'd have a true here, I'd have a false there, so then this would be true and the person would get a discount. Now, if I were to input, on the other hand, let me see, if I put in 30, then the Boolean here is senior would be false, is child would be false, and then when I go to this particular if else, is senior is false, is child is false, or together gives a false, so that we don't execute anything that's in the curly braces here. We would go to the else afterwards, and then whatever action you would have to take in order to not provide a discount would happen. And that's it for our intro to logic. We're going to move on to a little bit more detail about logical operations next.